Hello, hello. Are we live? Welcome back to the Advent of Sintran 2024. Today is day 11. Let's get into it. I'll download my inputs. The bitrate on my stream yesterday wasn't great, so the video was kind of jittery. I don't know why. I'm running my laptop over Wi-Fi, so maybe it's that, but I tried rebooting, so hopefully it's not worse. Yeah, I don't know. Alright, I should have my input. I don't think I haven't heard anything about today. All we have are 8 numbers? That's interesting. Usually the input is much larger. Let's see what we're doing today. So what's the example? Initial arrangement. So like that's not the whole input, right? I want to look at this. Okay, that's all there is. I was worried that like curl just downloaded part of the file or something. That's the whole file. Okay, what are we doing? What resolution am I streaming in? 1920. Well, the display is 1920 by 1200. I think this is... I think it's in settings. Stream. General. Bitrate. I feel like you get a startup thing. Okay, 1920 by 1080. Yeah, at least I'm not streaming in 4K, because that would not work. Stones, line with a number on it. Blink, they change. Ooh. Do I have to do a linked list? I don't know how to do a linked list in Sintran. Because I don't have pointers. 0 becomes 1. And then we divide the numbers in half by string. Okay, that's... yeah, I think I get it. I think I get that one bullet point. So if you have an odd number of digits, multiply by 2024. Okay. The order is preserved, so when you split... How many blinks are we doing here? Oh, 25 times? That's not so bad. Well, it's potentially like 2 to the power of 25. So, yeah, it grows exponentially. That's going to be a lot of stones. this is the test input. 0 becomes 1 because that's the first bullet point. Even numbers get split. Wait, oh, if it has an even number of digits, not if the number is even. Okay. Yeah, that makes more sense, because how do you split an odd number of digits? And then this gets multiplied by 2024. Zero becomes 1, 1 becomes 2024, 10 gets split into 2 stones, same with 99. Okay, I think that makes sense. The problem is when you split a stone, you have to shift everything after it. Okay, but we're just going to have like a temporary array. Okay. Yeah, we're going to have to recalculate the whole array on every step anyway. So yeah, the arrays are fine. You don't need a linked list. This shouldn't be that bad. Some of the rules are mathematical. That's fine. Multiplying. Splitting, that's a little bit weird. You have to like convert to string and then convert it back, kind of, or keep everything as strings, and then the math becomes weird. So, but the other day we had like a concatenation of digits, so this is not too different from that. Now we're splitting digits instead of concatenating digits. So let's save the test input. I think it was just 2 numbers, right? 125 and 17. Okay, and we're gonna blank 6 times for this example. And then they just want the number of stones. No. Oh, yeah, so 6 or 25. Okay. I think I got this. Let's edit today. This is just a template. By the way, well, it's right there. I'm now running Syntran.57. So I've been talking about this bug. It bit me on day 2, but I sort of figured out what was going on pretty quickly and just worked around it. Then, was it like 2 days ago or 3 days ago, it bit me again, and like it took me so long to figure out what the problem was. So I've updated Syntran. I've updated the version that I'm running here. There is no binary release for this yet, so if you're following along and you want to install Syntran, you can't install this version yet. You have to build it from source. You have to get the source code and compile it with a Fortran compiler. There's no other way to get it. Maybe later this month or sometime in January, I'll do an actual binary release, and that might be easier for people to install. So there's a caveat. Anyway, let's get back to the puzzle. So I think I'm going to have to look up the rules again. 0 becomes 1. So we're only going to have 1 line, so we don't need a loop to read the file. And then I just want to parse some integers from that. I have a feeling we're going to get... Are we going to get 64-bit integers? Let's do it just to be safe. We're going to have a vector of numbers. And they're just delimited by spaces. Yeah, just spaces. So split by space as a delimiter. And then we're going to do the rules. as a test, we'll just keep it at 6 because they show you all the numbers for the first 6 blinks here. So let's see if we can reproduce that, and then we'll bump it up to 25 blinks. IB is the blink index. I don't want to use I because I'm going to use I for more important things inside the loop. I don't think we're going to do anything with this number once we're in the loop, so I don't want that to get the good variable name. Okay, then we're going to copy the previous iteration of V to V naught. And then we're going to apply the rules. So, worst case scenario, V can become twice as big as it was if you split everything. My USB is making noises. I have like a USB switch that toggles between my personal computer and my work computer, which are at the same desk because I work at home. And it's just kind of switching by itself. Not switching, but like the computer is detecting the USB and it makes that ding dong noise. It's pretty annoying. I think I need a new switch. So this is going to be the size of the previous iteration. And we could do like multiple passes. Or we could just, worst case scenario, allocate twice as big. So V and then we're going to iterate over the values from the previous iteration in V naught. So that index is going to be I naught because it's associated with V naught. And then I also need an index into the new vector. So it's going to start out as 0, and then depending on whether we split or just keep one number, we're going to increment this by 1 or by 2 at each of these loop iterations. So that's why I have 2 different indices, I naught for V naught and I for V. So then we check the number of digits, and we split if necessary. I won't need to convert to a string every time, but for 2 out of the 3 cases, just 1 out of the 3? Just 1 out of the 3, but you have to check how many digits you have, so you kind of need to convert it to a string anyway, just to check which case it falls into. So, hey, Topco Wild, welcome to the stream. This language is Syntran. This is my language, which is interpreted, and the interpreter is written in Fortran. So if V naught I naught equals 0, it becomes 1. Whoa. Sounds scary. It's a little scary. Hopefully this language doesn't look too scary. It should look a little bit like Rust. Day 11? Yep, day 11. I've been doing each day on time. I'm on the East Coast, so I really don't like to stay up to midnight. On like 2 or 3 weekend days, I've done that, but most of the time I do this like 18 hours late after the puzzle was released. Okay, so 0 becomes 1, I think. So vi becomes 1, and we're going to increment I by 1. And then the other two cases are if we have an even number of digits or an odd number of digits. So else if that comment twice as big sounds interesting. Oh yeah, because sometimes you might split the digits. I'm doing this with arrays. So I don't have like a push function that automatically reallocates them like you might have for a vector. So I just allocate my next vector to be twice as big as the previous vector. And that's as large as it could possibly be in the worst case where you have to split every one of the numbers. So if we have an odd number of digits, mod 2 equals 1. No, even is going to split. Else. So that's splitting digits, and I think this is mul by 2024. I think that's what the rules are. This will not help spoiler. Please avoid spoilers. Just like to see if I can figure it out. There's probably going to be some kind of twist in part 2. I don't know what's coming yet. Okay, so splitting digits, we're going to do so we're going to parse the first half of the string. I think I'm doing I64, right? So we're going to parse v0 str. Let's get this in a variable. So 0 through len over 2. And then len over 2 through len. I think that splits because we converted to a string and then we have to parse that back into an integer. So this is like the scary looking case. And then multiplying by 2024 is easy. So vi equals v0 I0 times 2024. And then I don't think I need a comment for that. The digits get split in half, and then you create 2 different numbers. So let me reread the rules. 0 becomes 1. Even digits get split, and then, I mean, I don't think I need to do anything special for that. Parsing out of a string should just automatically do that. And otherwise, you multiply by 2024. So I think I have that. Let's see if I can get this example correct. I should print v at some point. And then I think I should also trim v because I double allocated this, it's going to have extra zeros at the end. So we're going to trim. V is going to be v0 through I. Yeah. I increment I after I set something, so I think that's correct. I think I want +1. am I printing? Okay, let's see if that works. In, for, in. Does it have linked lists? No, it doesn't. Yeah, I thought about that, and then I thought, well, it's really not going to be that bad to do it with arrays. For part 1, at least. Maybe part 1 is going to be terrible for arrays. Oh, I have a negative number. Why do I have... I think we did the first iteration and then it immediately failed. No, it doesn't have recursion either. So every time I need to do a recursive algorithm, I have to do like a stack or a queue-based algorithm instead, or an iterative version. So that made it kind of annoying yesterday when I had to do a depth first search, but I've done that before last year, so it wasn't too bad. Okay. It seems like I skipped over 125, and then I split the 17 into 17. So how did that happen? Let me print the initial V. Okay. It's not 0. Oh, I forgot to increment I here. I don't know if this is what you meant, but I don't have plus plus either. So I always do I plus equals 1. It's kind of like Rust in that regard. Maybe I'll add plus plus later. I'm not really convinced by Rust's argument that it's confusing to keep track of the difference between prefix and postfix. So I might do it later. I haven't really decided yet. Okay. So I guess that's multiplied by 2024, 253,000. Okay, the first blink is correct. And then I'm still crashing. I split 1 and 7. Okay, it should not be plus 1. I did not trim enough. There we go. Is that correct? You can kind of see it with the transparency. How about I do this? There, now you can see everything on one screen. 4048, 202. Excuse me, 44048. This looks correct. Ends with 032. The last few digits are right, or the last few numbers are right. V -1, is it? Oh, no. Yeah, it wasn't initialized with -1, but the problem was coming from the trimming. I thought, like, this takes a slice of the array. I don't know if that notation makes sense, but this is the way that I do slices. It's kind of like Fortran and MATLAB. So to fix the over allocation that I did in the beginning, I'm now trimming it down to the actual length, which is somewhere between the initial length and twice as much as the initial length. Golang style. Oh, yeah, I don't know Go, so that's cool that Go does it the same way. Maybe I should learn Go. I don't know. There are so many languages. I kind of want to learn a functional language because I don't know any functional languages. What? Oh, yeah. I just put that back in there. Why did I do that? Okay, so that's 6 blinks. Let's see if I can do 25 blinks. And we're supposed to end up with this many stones. That's a lot of stones. This is going to be printing a lot of stuff. And then I want to know, how big is that vector? Is this... size V, not V naught. 55312. I think that was correct. All right, let me try the real input. It might be printing too much that it becomes slow, so I can clean that up if I need to, but let's see. Something bad happened. I'm assuming I overflowed. No, I'm already using 64-bit integers. Does this like mess up the type? There we go. I accidentally had a 32-bit integer somewhere. 32 bits is the default. And then if you want to make something 64 bits, you can either do it like this, or you can do a casting style. So you can use the i64 function that returns an i64. So that is equivalent. I think this way is like one fewer character, so I've started tending to use that instead. All right, is this correct? All right, not too bad. Let's see how crazy part 2 is. 75 times. Okay. So I think you don't want to explicitly calculate everything. You just want to like keep track of how many digits it has. Hundreds of trillions. That's a lot. I do not have enough memory for an array that big. And my input isn't that big. Here's an idea. There are 8 numbers in this input. You don't have to do everything all at once. You could just work on this one number and do 75 blinks. And then you could do this one number and do 75 blinks. But that's only going to improve the situation by a factor of 8. So if you're getting hundreds of trillions and I divide that by 8, I'm still going to run out of memory. Yeah. So what do you do? So I could look at the rules in the puzzle text, but I think it's easier to just look at the 3 cases like this as code. So if you have 0, it becomes 1. If you have even digits, you split the digits. And if you have an odd number of digits, you multiply by 2024. Huh. I don't think I know what to do here. Yeah. Don't give me spoilers yet, because I'll think about it for a while. Skip this step. Rules do not matter. No formula. So the question is, does this give me a number with an even number of digits or an odd number of digits? And I think it just kind of depends. Like, I know that it's going to give me an even number, because if you multiply anything by an even number, for example, 2024, you always get an even number. But I don't know how many digits that has. $75. I think this is going to overflow. It just says 0. Okay. 2. Why do I keep hitting the wrong key? 75. But if I do floats, I could try I-64, but this is also going to overflow. Do I know what dynamic programming is? Is that what you mean? Oh. Oh, do you have to use dynamic programming for this? Because I know what it is, but I don't understand it. Like every time a dynamic programming problem comes up on Advent code, I'm totally screwed. Yeah. A couple times in the last couple years, I've looked at other people's code, and then I can kind of hack something together. But like, I don't understand it well enough to implement it myself. But if I do this as a float, it's 10 to the 22. Yeah, that's huge. It's not going to be that bad because multiplying by 2, again, that's the worst case scenario. But you could easily get into hundreds of trillions, and this is way more than hundreds of trillions. Oh yeah, lots of digits here. Well, if you don't like that many digits, you can do a 32-bit float, and then you only get half as many digits. Huh. Yeah. I'm either not going to get today, or I'm going to have to cheat. So I think I might just look at somebody else's code. Okay, I'm willing to accept spoilers. Do you have any more hints beyond just DP? Because even if you tell me that it's DP, I can't come up with a dynamic programming algorithm myself. I guess you have to sort of like remember which numbers you've seen before. Well, the test input isn't very interesting. So you have a 0, and you're probably going to end up with more zeros. So after like some steps of iterating after a 0, you know what vector you're gonna end up with. So if you ever see 0 again, you can just reuse that vector from last time. But I don't really know how to do that. Yeah, cache, it's like memoization. Memoization. Yeah. Well, I've had a good run. I got all 20 stars until today, so it's about time that I didn't get a star. Value is not enough for cache. One more piece is needed. Not sure. Yeah, I'm not sure what that would be. I guess you also want to know which step you're on, like how many blinks into the process you're in. Because if you start at the very beginning, you have 75 blinks to go. But then if you've done a certain number of blinks and you only have, let's say you've done 25 blinks, you only have 50 more blinks to go, then you don't need to like look up the cache 75 steps later. You only want to look up 50 steps later. So maybe you need the value and the blink that you're on. Yeah, not the step that you're on, but how many steps are remaining. What was my part 1 answer? 180,000. Number of items produced for each particular values after particular steps is constant. Yeah. So if you see a 0, it's always going to grow the same way the last time you calculated a 0. That's not going to change. Okay. So maybe I can do this. So I was worried that I would have to like store the vector that I end up with. But you only need to know how big the vector is. You don't need these values in the vector. You just need the size of the vector. And that's the only result that I need to cache. Do I have a map or a dict? No. I have arrays. So I have structs. I don't think that helps though. I think you can do this with arrays because you can cache values that you've seen before in an array. Or can you? Like, is the growth of these numbers limited? Let's see what that is. This will be ON, not O1. Do I have max built in? I don't think I do. Yeah, not for that. I don't think I have max val, which is what Fortran calls it. No. Time to implement map with a hash function. Well, that's easy. We did that last year in Advent of Code. Oh, and to look it up in the array. I'm wondering like how large of a value I get. So could I just index into the array and not like scan through the whole thing? So it would be O1. But if these numbers grow uncontrollably, then that's not going to work because I won't have enough memory to do that. And then I need like a hash or a map or a dict, like you say. Yeah, I can check this in a second. Just have to see, how do I get the max? I have to use a loop. That's the only way I can get a max. So that's not too bad. For I, let me use J because I is already something else. Let me do it up here. Yeah, that's slightly easier. NV not Vmax equals max Vmax V naught J. Everything has to be 64-bit. They might not be. I might be able to go down to 32-bit. Or no, I think something did overflow when I had that mistake earlier. Oh yeah, these are huge. So I need a dict. I really don't feel like implementing a dict. It's 400 billion. Yeah, that's big. I think I'm going to have to call it today. I don't think I can do this. Maybe off stream. Yeah, I don't think I'm going to struggle through this on stream. Or it's not going to be ideal, but I could try it with an array and an order n lookup. That's like the poor man's dictionary. Part 1 is already taking almost a second. Can I go up to 30 steps? Okay. Going from 25 steps to 30 steps. Yeah, you also got something pretty big for pretty similar to mine, I think. Is that after 25 or after 75 steps? 400 billion. And I was getting... Which one of these runs is which? Yeah, I also got like 400 billion, so it's very similar. And you got 409 billion after 25. Okay. Yeah, arrays are still not great, because then how would I insert something into my array-based dictionary? Store in pairs. Oh yeah, it doesn't have to be sorted. I was thinking if I wanted to have it sorted, then I would have like an expensive insertion operation, and that wouldn't work very well. But it doesn't have to be sorted, so I can just append it to the end. Yeah, I guess it's worth a try. Okay, so let's take part 1 and copy that. And this will become part 2. So I can just run part 1 twice. Oh, the length of the cache, that's manageable, only 128,000. So even if I have to scan through that whole thing to do an order n lookup in my terrible dictionary, I think that might be manageable. And then I might have to do that like 75 times 100,000 times. So overall, it's going to be kind of n squared. But I think that should be manageable at the order of 100,000. Okay, I guess I'll try it. several arrays and treat them as buckets. Yeah, I still struggle with DP because I have to start from nothing. I have to start with no cache. So how do I build up that dictionary while I'm also calculating the dictionary? And I don't have recursion either. So does that matter? Yeah, I think you have the number of steps remaining, and then you recursively call some function, and then within that function you subtract 1 from the number of steps remaining. So I don't have recursion, and I don't have dictionaries. I think those are two things that would both help with this problem. Yeah, I think I have to call it. I don't think I can do this. Let's make sure I can still do part 1 at least. Okay, I'll commit what I have, and I might try to hack at this off stream. Q should work. Yeah, but then you have extra state. For depth first search yesterday, that wasn't too bad, but I don't know how much state I'm going to need here. Is that what I submitted? 183435. Yep. Okay. Yeah, I'm just going to commit what I have for part 1, and I guess I'll find somebody to raid. AOC 2024, day 11, part 1 only. Maybe I'll do part 2 at some point. Okay. Let's see who else is on Twitch. Is anybody else doing AOC? None might be doing AOC. What about this guy? I tried to raid ads. Yeah, I'll just raid none. Where to look at other days implementation? Oh, yeah, there's like a Reddit, and there are a couple YouTubers that I watch, so I might actually watch their videos and then also look at their code. So I think I have several resources. Anyway, thanks for the help. I just wasn't smart enough to come up with DP and memoization and dictionaries myself. So thanks to anybody else who tuned in. I appreciate it, and I will catch you next time. Bye.
A website or whatever. Ship testers for free. It's hilarious. Hello there, Jeff. Welcome in. How are you doing today? Do you finish admin code like day 11 or something like that? Jeff, welcome in. Shout out to Jeff, you guys. Jeff is a friend of the stream, and he has been working on admin code. Definitely so much better than me if you guys want to check out. And do you do it in Fortran, Jeff? Oh, you only got part. You only did part one today. I see. I see.